All right, folks. Yes, this is our last video. I don't know if it's 9-8. I assume it is, but this is lesson 8. 8 or 9. I think it's 9, actually. So this will be the 9th lesson of series, and we're going to talk about radius and interval of convergence. And that's it. So I have here what it means, what the radius of convergence means. It's for a power series centered at C. Precisely one of the 3 choices are going to be true. So you're going to have one of 3 choices here. All right? If the series converges to A, then I can set the absolute value of x equal to that number, and the radius of convergence is 0 because it equals the number. There's no x in there. Okay? There's no x at all. The next one says, so that's the first one. The first one says, like, if you get it equal to a number, there's no radius of convergence because it's that number only is where it converges. The next one says, I don't know if you remember these symbols, but I figured I'd end on my last symbolism here. There exists an r greater than 0 for that's a real number such that the series converges absolutely for x minus c, take the absolute value less than r. Okay, it'll diverge for the absolute value of x minus c greater than r. So that means, it's a lot of jargon here. That means that if you get an answer of something with x, you have to make sure it was centered at c, just like the Taylor series. If it was centered at 5, you would do x minus 5. Okay? Here, if you get like x, 2x as an answer, centered at 2, it would be x minus 2, and you let that equal be less than r. Okay? That and you solve it. That's it. If you really want to know. So when you get values of x, and we'll see examples of these. The third one means the series converges absolutely for all, remember that upside down A is for all x. That means that the series converges for every x. Okay? And that the radius of convergence would be infinity. That means that it converges for all of them. The radius of convergence is the whole number line. Okay? The set of all values of x for which the series converges is called the interval of convergence, and we make interval notation. All right, I have some examples here, so let's go over them, and they're worked out already. So I have this example of a series that goes from 0 to infinity of n factorial times x of n. I'm going to do the ratio test on this thing. So when I do the ratio test, I get, as you can see here, n plus 1 factorial over n factorial. And this is x to the n plus 1 over x to the n. So what's going to happen is, on top, I'm going to have an n plus 1. And then when I cancel or simplify the x's, I'm going to have an x. Go ahead, Ryan. Don't matter. All right. So the limit as n approaches infinity of the absolute value of x times n plus 1 equals infinity. Oh my God, you get it equals infinity. That means it diverges. That means it will only converge of a radius equal to 0. So x equals 0. That's it. It'll only converge when x equals 0. Okay? That's it. Because then the infinity does not matter. That's what that means. So you got to use your head a little bit and think. If x equals 0, that's the only place it will converge, because then this would be a number. Radius of convergence is 0, and it is that number 0. All right? I hope you get that. All right? Right here. If I plug 0 in here, it wouldn't matter what n is. The answer would be 0. Next example here, once again, I use the ratio test. Favorite test, I guess. All right? And you see me using the ratio test, and you get x minus 2. Well, guess what? I forgot to tell you, the radius of convergence is always 1. So we set it always less than 1. I forgot to tell you that. So now we're going to say the absolute value of x minus 2 is less than 1. Oh my God, that's where it converges. So we can figure out the radius of convergence. And what we do is we do the absolute value, the definition of the absolute value. We add the 2 to both sides, you get x less than 3. We add the 2 to both sides and change the sign here. So you get 1 So our interval of, so this is where it converges. Okay? The radius of convergence, well, if the center is 2, it went from 3 to 1. That's why the radius of convergence is 1. Fantastic. If you want the interval of convergence, it's 1 and 3. That's it. The interval from 1 to 3. Now, I need to test the endpoints because those endpoints could make it convergent. So let's do that. If I plug in over here, where am I plugging 1 in? Okay, it says I do test the endpoints, but I don't see me testing any endpoints. All right, let's come back to the I do test the endpoints thing. Okay, let's erase that. See, we can just erase our memory like that. Last one example, I think here. I might even have another slide of examples, but the last one is this one. We do the ratio test. It doesn't matter because we're doing absolute value, so that'll take care of the -1 here. And when the smoke clears, this is 2n plus 1 factorial, 2n plus 3 factorial. Okay, so we can forget about the factorials, and we have x to the 2n plus 3 up top. So we have this, I think. We get x squared over 2n plus 2, 2n plus 3. All right? That guy's equal to 0. It's less than 1, which means it'll always be 0, which means it's always less than 1, which means the radius of convergence is infinity. I think Jake Zlochnik is behind me. Jake, say hello.
Hey there.
There he is. All right. This is our last video, so we have to have some special guests in this, okay? He's rubbing up against me. All right, here we go. Next, endpoint convergence. This is what I was talking about before. You have to test the endpoints. So when I got this guy, 1, 3, I need to test the endpoints. So when I test the endpoints, watch, x minus 2, you plug into the original. So I'm going to plug them into the original and see if they converge or diverge. So when I plug 1 in there, I get this. -1, so r equals -1 does not converge. However, when I throw 3 in there, I get 1 and no endpoints yield convergence because they were both 1. Let me show you one that does work on the endpoints. So here's x to the n over n. We do the ratio test, okay? And we get 1. Okay, radius of convergence is 1 because it started at 0. Okay, remember it starts at 0. And now it goes, the absolute value says it goes from 1 to -1. So the radius between them is 1. Makes sense. Now, I have lots and lots of stuff here. I don't know what it means, but let's follow it. So we're going to test the endpoints. So I'm going to test 1 and -1. All right? So I test -1 into this, and this now looks like alternating series, and it converges. So -1, check this out, -1, -1 is a convergence one. So we close the endpoint. However, if I put in 1, now it's not an alternating series, it's a harmonic. Harmonics diverge. So only -1 gets it. All right? I have some homework for you. My homework for you to try is 5 to 17, and we'll go odd. All right? You have all the answers in the back. So try 5 to 17 on page 668 odd. This has been a great year, hopefully. We're going to get into review mode big time. And, you know, I hope you enjoyed the videos at least. All right? You'll get a nice little thing at the end about how you learn better, either with me teaching or the videos. All right? This is Frank Maracchio signing off for 2013. You know, ACM.